Good evening friends. This is our fifth video and today we are going to discuss conic sections. So we know that it is very important topic. So conic sections include that parabola, ellipse and hyperbola. So already how the sheet we divide. So different division of the sheets last class we discussed already. So today we will see general method. So we have different methods of parabola, different methods of ellipse, different methods of hyperbola is there, and for combination of all, one method is there. It is called general method, or we can call it is eccentricity method. So by using this method, we can go for ellipse, parabola, or hyperbola. Okay. So today we will see this eccentricity method. Okay. Now, so this is eccentricity method, or we can call it is general method. So in examination, so first we will see today. So what is parabola actually? How to identify the parabola or ellipse or hyperbola? Okay. So in examination, question he may ask that. Draw a curve by using eccentricity method or general method. Directrix to focus distance is 50 mm, and draw a tangent and normal at 40 mm. Okay. So here the only hint is directrix means assume that point A. Directrix to focus is equal to 50 mm. It is one point is given, and another point is tangent at 40 mm. This is a given data actually. This is given data. So by using these two, we have to draw the parabola first. We go for parabola. Okay. So here what we have to do, the procedure is, so listen carefully, procedure is first to draw a vertical line, and this vertical line we call it is directrix line. This vertical line we call it is directrix line, and you can start anywhere. Draw a horizontal line or perpendicular line. This horizontal line is called axis line. Okay. So two lines. One is vertical line, it is directrix line, and horizontal line is axis line. Okay. So starting these two intersection point, that mark point is A. This is the directrix point. We call it is, this point A is, we call it is directrix point. So directrix to focus. So length is given 50 mm. So mark here 50 mm. So this distance is 50 mm. Okay. And this point is focus. So here directrix to focus is given 50 mm. So take by using the scale 50 mm. Mark 50 mm. Now here the miracle is, here the vertex fixing is very, very important. Depends upon the vertex movement. It depends upon the vertex point movement. The curve changes, whether it is parabola or ellipse or hyperbola. So that is the miracle. So how the vertex fixes, we see here. So this method is not there in the textbook. How to arrange the vertex pointers? So see clearly here. Suppose we know that suppose here we are drawing parabola. Parabola. So what is the eccentricity of parabola? It is equal to 1. Eccentricity of the parabola is 1. Eccentricity of the ellipse is less than 1. Eccentricity of hyperbola is greater than 1. So eccentricity of, what is eccentricity actually? What is the meaning of eccentricity? Eccentricity is equal to a distance from focus to vertex. Vertex means V. Vertex divided by vertex to directrix. Directrix point is A. So that is FV divided by VA. So meaning of it is the vertex point is always between directrix and focus. Between these 2 points, it may be here or here or here, whatever it may be. That is depends upon given data. Okay. So here Fp by V. So the meaning of it is, suppose eccentricity of parabola is 1. How you will get 1? So here directrix to focus is given 50 mm. So if you take 25 divided by 25, so Fv, suppose assume that Fv is at midpoint. V is at midpoint. So this zone is 25 and this zone is 25. So Fv is 25 divided by Va is 25. So 25 divided by 25 is equal to, you will get 1. So we can decide that the eccentricity is equal to 1 means the name of the curve is parabola. In the same manner we can go for hyperbola, ellipse also. That will say later. So first we see the parabola. Okay. So parabola eccentricity we got 1. So now we can decide that the vertex point of this curve is at midpoint. So A to F is given 50 mm. At 25 you mark vertex points. Okay. So now vertex we fixed. Now what we have to do, next procedure is draw a vertical line through the vertex point, and that vertical line should be parallel to directrix line. Listen carefully. Draw a vertical line and that vertical line should be parallel to directrix line, and it is passing through vertex point. Now vertex is the center, V is the center, up to F is the radius. Draw a semicircle. V is the center, up to F is the radius. Draw a semicircle. So it touches this vertex extended line at these 2 points. So here write small a and small b. Now A to F, join A to B and extend the line, and A to small a and extend the line. The meaning of it is, these 2 inclined lines, it indicates that it is the limit of the arc. So the arc should not cross this limit. Okay. Now what you have to do? Now the important point is vertex point. So always curve touches from the vertex point. So vertex and focus, these 2 points remember now. 2 points remember now. Now from the vertex point, take number of points on this line. Whether equal lengths or unequal length, as your wish. So just blindly you take 1, 2, 3, 4, 5, 6 as your wish. In examination you can go up to 10 points. Depends upon your time availability. So give the numbering 1, 2, 3, 4, 5 and 6. Now from all the points, draw a vertical line. It should touch these inclined lines, and these vertical lines should be parallel to directrix line. So from 1 we are drawing, from 2 also I am drawing the line, from 3 also I am drawing the line, from 4, from 5, like that you can go for up to 7 or 8 points. Okay. And suppose this is point 1. So give here numbering. Suppose this is 1. So here is 1 dash, where the inclined line cuts the point, that is 1 dash. And in the bottom side also same numbering you can give, 1 dash. And this is the 2 point. So this same line, it is touches here, this is 2 dash. And downside also 2 dash. In the same manner, 3 dash, 4 dash, 5 dash, you can go for up to 8 dash. Okay. 3 dash, 4 dash, 5 dash. Like that you can go for 5, 6, 7, 8, 9. Now 80% of the work is over. Now just to mark the points, how to cut the point, just to see here. 1 to 1 dash is the radius. I am writing here, just to copy this. 1 to 1 dash is the radius. 1 to 1 dash is the radius. F is the center. And cut the 1 to 1 dash line. And cut the 1 to 1 dash line. So this is the standard procedure. Okay. For all the points, you must follow this rule. So see here once again. 1 to 1 dash is the radius. With compass, you take 1 to 1 dash is the radius. and F is the center. F means focus. This focus point is there. So F is the center, and cut the first line. Which length you took, which radius you took, 1 to 1 dash, which line, same line you have to cut. But always you must go for F is the center. Suppose second line if you go 2 to 2 dash is the radius. So F is the center and cut the second line. So I am cutting here. So 1 to 1 dash is the radius, F is the center and cut the first line. Both sides you can cut at a time. So you will get both sides at a time. Both sides you will get a curve at a time. So 2 to 2 dash is the radius, F is the center and cut the second line. In the same manner, 3 to 3 dash is the radius, 3 to 3 dash is the radius, F is the center and cut the third line. 4 to 4 dash is the radius, F is the center and cut the fourth line. 5 to 5 dash is the radius, F is the center and cut the fifth line. So for suppose first line cutting point you can give the marking P1, this is second point is P2, third is P3, P4, P5. In the same manner here also you can give P1, P2, P3. Okay. Now join all the points with a smooth curve with your free hand sketch. Okay. No need to go for any instruments. These are all handmade curves. We cannot go for with any instruments. So join these all the points with a smooth curve through this vertex point. So like that, so this arc is called parabolic arc by using eccentricity method or general method. And next is given tangent and normal we have to draw at 40 mm to the curve. Okay. So what you have to do, from the directrix you take 40 mm where you are getting. Suppose if you are keeping scale like that 0 to 40 like that, you see the scale where you are getting from this point to this point 40. Assume that suppose 40 you are getting at this point. Okay, this length is 40 mm. Assume that 40 mm. So mark this point is M. Always the point name is M, is midpoint. That is. Join this M point to focus by a straight line. Join M point to F with a straight line. And draw a perpendicular line from the focus. Draw a perpendicular line from the focus and extend up to directrix line. So it touches on the directrix line. Okay. So see here once again I will explain. M is the midpoint. That how we mark this M point. It is 40 mm from the directrix. So parallel to this horizontal line, 40 we are getting here. So mark the point M, and M point and F point join by a straight line, and perpendicular to this line extend the line up to directrix line. So we are getting here. So now join this point and this point, this directrix point and M point by a straight line and extend the line. This line is called tangent. We call it is tangent. Why? Because it is touching the curve. Touches at one point to the curve. It is called tangent. And at M point draw a perpendicular to this line. It is called normal. Normal is always perpendicular to the tangent. Okay. Once again I will explain clearly. So listen all of you. The problem is draw a parabolic curve of eccentricity is 1. Of eccentricity is 1. By using eccentricity method or general method. So the given distance is directrix to focus is given 50 mm and tangent at 40 mm. That is the question. Okay. So now what you have to do? How to draw this procedure? Draw the vertical line. It is called directrix line. And draw the horizontal line. It is axis line. Axis line. And starting intersection point, mark point name is A. It is a directrix point. Directrix point. So directrix to focus is given 50 mm. So take A to F is 50 mm. Mark these 2 points you will get A to F. So eccentricity is equal to, it is the ratio of focus to vertex divided by vertex to directrix. So that is FV divided by VA. So it is that meaning of it is eccentricity of parabola means 1. How you will get 1? Whatever the distance is there, if you take midpoint, so you will get directly 1. So it is 25 divided by 25. Why? Because 50 is given. So 25 divided by 25. Suppose 100 is given, you take 50 divided by 50. So you will get 1. So the meaning of it is you must take the center point. If you take center point, automatically you will get parabola. So that is vertex point. So mark the vertex point and by through the vertex point draw a vertical line. That vertical line should be parallel to directrix line. Okay, so now we have 3 points: directrix point, vertex point, and focus. Okay, now curve starts from vertex point always. Okay, now from vertex point take number of points on this line, either equal points or unequal points. So just to blindly mark 1 2 3 4 5 6 7 8 like that. Now project all the vertical lines. Draw the all the vertical line from all the points. Suppose 1 line, 2 line, 3 line, 4 line, all extend all the lines. Before extending the line, you must draw this border. Now vertex point, after getting vertex point, V is the center, up to F is the radius. Draw a semicircle. So it cuts 2 points, small a and small b. So from A to small a and extend the line, A to small b and extend the line. These two are the limit of the arc. So then mark the 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, like that. Mark all the points, top and bottom. Now take the radius is equal to 1 to 1 dash is the radius. 1 to 1 dash is the radius. Okay. Now 1 to 1 dash is the radius. F is the center, focus is the center, and cut the first line, both sides. In the same manner, 2 to 2 dash is the radius, 2 is the center, and 2 to 2 dash is the radius, F is the center, and cut the second point, both the side. In the same manner, 3 to 3 dash is the radius, and F is the center, and cut the third point. Like that 4, 5, 6, join all the points with a smooth curve, you will get parabolic curve. Okay. Now for tangent and normal, it is given distance from the directrix 40 mm to the curve. So parallel to this line, just to move the scale, where we are getting from 0 to 40 to the curve, so mark that point name is M. And from M, directly join to the focus by a straight line. And perpendicular to this line, extend the line up to directrix line. So this is called, this line, mark the point here. So join this point and M point and extend the line. This line is called tangent, and perpendicular to this line is called normal. Okay. So this is regarding eccentricity method. It is very important method. It is very important method, and in examination there is a chance of getting 90% in examination. Okay, next video, next class we will see that in same method how to go for ellipse and hyperbola. So same method is there, but small change is there, that we will see in the next class. And everyone, I will request that please subscribe this channel. Why? Because coming videos also very impressive and interesting. So like everyone, and share the videos, and please share this knowledge to your friends. Okay, and subscribe my channel and encourage me. Please cooperate, and give your any questions or any doubts is there. So coming video I can go for better with your comments. So please comment me. Thank you.